Hello, my name is Bob Evans, and I'm going to explain the basics of retaining wall design, the things that you need to be aware of when you're looking at retaining walls. So on the website you'll see lots of retaining walls, but mainly they're categorized into two retaining wall types: cantilever and gravity. So you can see these are all cantilever retaining walls and these are all gravity retaining walls. The gravity retaining walls use the mass of the wall to resist the earth behind it, whereas the cantilever tend to have legs, and the earth sits on top of that leg, and that helps it work. And then we have some forces at the bottom here that we need to be aware of. But basically they're the two types. Retaining walls are designed by structural engineers, and they use a British standard code to do that, and this is the code BS 8002. There's a lot more to it than just this code, because we've got soil mechanics to consider and masonry design and reinforced concrete design, but it's all carried out by structural engineers and geotechnical engineers. Let me just show you some of the modes of failure. So the engineers are looking to design walls to resist these failures. So the first one is overturning, where the wall can topple over from the load being pushed against it, and it'll topple over like this at a point. It could be at the bottom of the wall, or it could be a joint of the wall. We have bearing capacity failure, where the ground isn't sufficient or stiff enough, or the ground bearing pressure isn't great enough to support the weight of the wall. That can cause failure. The wall can slide, so the horizontal force will push the whole wall and the foundation to one side, so that's sliding. Stability is that the overall situation for the ground condition, so the whole ground can slip, so it's important to understand the geotechnical engineering of the earth and the soils. And we have shear, where the wall can actually shear off the base or a joint, again from the forces pushing the wall over. So they're just some modes of failure. Let me show you and make this simple with a simple demonstration. Okay, next. So a structural engineer needs to understand the ground information before he can design a wall. The subject is called soil mechanics. It's a big subject which we can't go into, but let me try and make this simple by just explaining site investigation, boreholes, trial holes, desktop studies, and contractors who can actually carry out the work. So first of all, let's look at site investigation. So what is it? So basically this is where we're going to drill a hole into the ground to a depth of 4 to 6 to 8 meters, and then we analyze the soils as we're drilling the hole. There's all sorts of ways and methods to do this, but we just need the guidance of a structural engineer to find out what he wants to design the wall. And the result of this is we get a bore log. And so this is what a bore log looks like. So you can see the depths of various strata in the ground, and there's numbers here which are testing the soil as they're penetrating it, and this information is then given to the structural engineer, who can then design the retaining wall. The other method is to excavate a trial pit. So a trial pit is a hole we just excavate with a JCB or other type of machine, or even by hand, and we can then look at the strata at a local level. These pits normally go down a meter, 1.5 meters, and we can also check the soils at the bottom of the pit to make sure we've got reasonable ground for ground bearing pressure calculations. So that is a more local way how to do it. We can also go to the British Geographical Survey website and find borehole information in your local area. There's a massive database. You just put your postcode in, check the boreholes, and it'll give you a list of boreholes in your area. And this also shows the geology of the UK. And then you can pick on a borehole, click on it, and it can tell you all about that borehole. So that's a desktop study method of trying to analyse and find out what the soils are in a particular area in the UK. But my experience and best knowledge I can give you is to employ a geotechnical engineer to do the site investigation work on your behalf, and that can then go to a structural engineer. Let me show you some case studies. So this is a case study of a project in Cumbria where we built a inclined concrete block retaining wall. So that's what it looked like when it was being constructed. And the engineering of it, the particular soils in this case were 100 kilopascals. So we had to engineer the wall to allow for that poor soil condition. And you can also see there's a surcharge up here because the top of the earth at the top of the wall sloped backwards, adding more load. So this is all very important information for the engineer. This is another case study project in Somerset. So you can see the detail that engineers do. They'll summarise the design and just confirming the information they had to actually design it, and they'll do some drawings, and the output of the design normally is a set of calculations, looking at all the various calculations for overturning and sliding and slipping and ground bearing pressure, etc., etc. And then finally the output is a drawing for construction. So the contractor can actually build the wall in accordance with the structural engineer's design, and this way it won't fail. So the important lesson here is retaining walls must be designed by a structural engineer using soil information from a geotechnical engineer to ensure the retaining wall will not fail in the future. That is my opinion. What to do next? So if you have a retaining wall and you want it to be engineered, let us know, or ask a question, or complete a form on the page. Thanks for listening. Bye.